This title is about pure inductor in alternating current circuit. First, let's define what pure inductor is. A pure inductor is a coil. So remember, this is the symbol of a coil with a self-induction, because every coil has a self-induction. L, we know that. We studied in chapter 6, section 1. With negligible resistance R. Yani resistance of this coil, we will assume that 0. So this is called a pure inductor. So why do we do that? Why? In fact, it's impossible for a device, for a wire to have 0 resistance. In reality, a coil will have both L and R, but we will start with the ideal cases. Then after that, we will apply this to a real case. And there are some chapter questions about the real coils, but first we will start with a pure inductor with only inductance but no resistance. So this is the coil which has an inductance cell connected to an AC generator with the equation of potential difference V m sine ωt. And again, we connected a voltmeter between the ends of the coil to measure the potential difference, and ammeter, which measures the electric current through the coil. Inductor is a little different than the resistor, because in resistor we know that electric current reading of the voltmeter and ammeter was proportionally changing, but now there's a time delay, there's a difference in the reading of ammeter and voltmeter in a coil because of the self-induction. If you remember, when we are talking about the self-induction, when the electric current in the coil is changing, the coil was reacting and then inducing a oppositely directed electric current, which is known as self-induced current. Because this is an alternating current, electric current on the coil is continuously changing, and this changing electric current induces an oppositely directed current, which is self-induced current. And then that's why when you start the circuit, potential difference between the terminals of the coil gets maximum value. As soon as this becomes maximum, that becomes maximum. However, electric current cannot becomes maximum because of self-induced current. This part is not explained in your book, but the reason is this. Because of the self-induced current in the coil, there is a time delay for current IL supplied to the coil compared to potential difference VL across the pole. Yani VL becomes maximum, but IL starts from 0. So it takes time for IL to get the maximum value. So for that reason, this reading of the voltmeter and ammeter will not be proportional. So reading of the voltmeter and ammeter will change like this. As reading of the voltmeter maximum, so then electric current will be 0. Reading of the ammeter will be 0. Or voltmeter reading is increasing, ammeter reading will decrease. If voltmeter reading is decreasing and ammeter reading will increase. If voltmeter is 0, ammeter will read the maximum. This is completely opposite of resistor. In resistor, they were proportional changing, but now they're inversely changing. So this inverse change in voltmeter reading and ammeter reading is explained as being out of phase. Yani, if you look at this graph, you will see that as initially voltmeter reading is maximum, ammeter reading is 0. Then voltmeter reading is decreasing, but ammeter reading by the time increases. As voltmeter reaches 0, ammeter reaches the maximum. As voltmeter reading is increasing in opposite direction, a negative value, so voltmeter reading is voltmeter reading increasing, ammeter reading is decreasing. So then, as ammeter reaches 0, voltmeter reaches the negative maximum. So when one of them is 0, the other one is maximum. When one of them is increasing, the other one is decreasing, and vice versa. So in a pure inductor, electric current IL and potential difference VL are out of phase. They are not in phase. They are out of phase. What is this phase angle? Pi over 2. So why pi over 2? If you look at them, So this is potential difference, this is electric current, and this is one half cycle. Remember which one half cycle corresponds to pi radian. Full cycle corresponds, remember, to pi radian. This difference is pi, remember, or that difference is pi, but half of pi is pi over 2. So the difference, phase angle difference between the red and blue graph is pi over 2, which is 90 degrees. That's why we say that in a pure inductor, electric current IL and the potential difference VL are out of phase by an angle of pi over 2. Which one is leading? The potential difference across the inductor leads the current by a phase angle of pi over 2. Because when you start circuit, so then if the potential difference, as soon as if this generator reaches the maximum value, that reaches maximum value, but electric current cannot get the maximum value. There's a time delay. Electric current becomes late. For that, is the potential difference is leading. Electric current, we say that lags behind. Leading by pi over t is also represented by two vectors perpendicular to one another. So this is the electric current, IL, Im sine omega t. So then potential difference must lead electric current by a phase angle pi over 2. That's why vector of potential difference is represented vertical if vector of the electric current is represented horizontal. And then equations are also a little different. IL, electric current, Im, if written Im sine omega t, potential difference equation becomes Vm sine omega t plus pi over 2, y plus pi over 2, because potential difference is leading electric current by this phase angle. Again, we use the Ohm's law. According to Ohm's law, VE over IE, or Vm over Im, defines a property of the coil. Remember, this ratio always defines an opposition of that device to electric current. So remember, in the resistor it was called resistance. So in resistor it was resistance, but here resistance is 0. In pure inductor we said that it's 0. Something else also resists the electric current, changing electric current on the coil. That property, that opposition of the coil to the flow of electric current is defined as inductive impedance and represented by XL. XL, again, Vm over Im and Ve over I. It's the same way of the Ohm's law we calculated R. But this opposition is due to the self-induction, but for the resistor, opposition was because of the collision of the electrons with the atoms. There's a difference in the nature of these oppositions, but their effects are the same. So the unit of the inductive impedance, again, volt per ampere, which is equal to ohm. Volt per ampere, which is equal to ohm, the same as the resistance. Resistance also has a unit of ohm. Inductive impedance, XL, also has a unit of ohm. This is how we calculate the XL, but what causes XL? So now we will talk about a little nature about the inductive impedance. The inductive impedance XL is the opposition of the inductor to the flow of electric current. So inductive impedance XL depends on two things. One of them is coefficient of self-induction, L. Second one is the frequency of the AC generator, F. So why is it like this? Because remember, as I said, opposition is the conductor, which is related to self-induction. If coefficient of self-induction is big, which is opposition, becomes greater. One of them is this. Self-induction becomes greater. Second one is frequency. Why frequency directly proportionally changes the XL? Because the coil resists the change in the electric current. If you increase F, which means you are making a change at a greater rate, and then that's why this coil will resist, or resistance of the coil, or the opposition of the coil to the electric current will increase. That's why XL is directly proportional, both L and F. So 2 pi f, L is the equation for calculating XL. Sometimes 2 pi f is not given, only omega is given, because omega, remember that 2 pi f, we can also write it. Omega L, or 2 pi f L, is the equation for calculating inductive impedance. So this equation gives information to us What is the nature of inductive impedance? Nature of inductive impedance depends on the inductive impedance and depends on the frequency of the generator. As you see, if frequency increases, inductive impedance increases, or decreases, inductive impedance decreases. But it was not the same as the resistor. In resistor, resistance was independent of frequency, but here XL is depends on the frequency, even directly proportional with the frequency. And let's solve some problems about this. First problem is calculate the self-impedance of the coil of self-induction 0.04 Henry. So L is given as 0.04 Henry, connected across a source of frequency 100 Hz. F is equal to 100 Hz. Calculate self-impedance or inductive impedance, sometimes called inductive impedance, sometimes self-called XL. Questions calculate XL. We know that XL is equal to 2 pi F L. Just multiply them. XL is equal to 2 pi 6.28 multiplied by F, which is equal to 100. L is 0.04. So if you multiply them all, you will get the answer as, let's multiply them at 6.28 multiplied by 100 multiplied by 0.04, which is equal to 25. XL is equal to 25 ohm. It is the inductive impedance of this coil. Next one. An AC source of instantaneous value, V is equal to 10 sine 50 pi t feeds a coil of self-induction 0.1 Henry. So then L is 0.1 Henry, and generator is feeding this coil with an equation. This is the equation for generator. 10 sine 50 pi t feeds this coil. Find the maximum value of the current through the coil. Calculate I maximum, but in the coil. And the phase difference between the potential difference and the current. We know the phase difference between the current and potential, which is pi over 2. Remember, it's given in the coil as an information. Potential difference is leading the electric current. But for calculating IM, we need to know what VM is, because just we have one equation, which is Ohm's law. There is no other way for finding IM. In this question, VM over VM over XL. VM is given, yes, it's given here. Remember, equation for a generator is equation. V is equal to VM sine omega t. What is written here? VM is 10 sine, what is omega? 50 pi t. So VM is 10, omega is 50 pi. So then omega required for finding XL, 50 pi. So by using omega, let's calculate XL. XL is omega times L. 50 pi 3.14, L is 0.1. So then if we multiply them all, we can calculate what XL is. Let's calculate it. 50 multiplied by 3.14 multiplied by 0.1 is the 15.7. This is the XL. And now we are ready. Let's insert it, XL here. VM is 10. Let's insert it here. Calculate IM. IM is equal to 10 divided by 15.7. Let's calculate it. So 10 divided by answer 15.7, which is equal to 0.60, almost 64 ampere is the maximum value of the current through the coil. And sample problem, It says that a coil of pure self of L is equal to 0.2 Henry, and L is given as 0.2 Henry, and negligible resistance, which means R is equal to 0, which is a pure coil, is connected across an AC source of frequency. When it's talking AC source, it's a generator, of course. So when we say AC source generator, frequency of this generator is 50 Hertz. Find the self-impedance of the coil, calculate XL. An effective current thread, calculate effective current. If the effective potential difference is 125.6, effective potential difference is 125.6 volt. So then write down the expression for instantaneous current potential difference across the coil in terms of time. So we will write it at the end. Let's calculate first XL and IE. So XL, remember it was 2 pi FL. So then XL, 2 pi, 6.28. F is 50 Hertz. Multiplied by L is 0.2. So let's multiply them all. 6.28 multiplied by 50 multiplied by 0.2, which is equal to almost 63 ohm. This is XL. Next step is calculate effective current. Effective potential difference is given. Just use Ohm's law. IE is equal to VE divided by XL. V is 125.6 divided by XL 63. So let's do it. 125.6 divided by answer, which is equal to 2 ohm. 2 ampere, sorry. Effective current is 2 ampere. Effective potential difference is 125.6 volt, and the XL is 63 ohm. Now write down the expression of the instantaneous current and potential across the coil. Remember the equations. IL is equal to Im sine omega t. We did this in the resistance part. But VL is Vm sine omega t plus pi over 2. Remember, potential difference was leading the electric current by pi over 2. So write the next expression means just insert these constants Im, omega, Vm, and omega. Insert them into the equation, which means you finished writing down the expressions of the instantaneous current and potential difference. So omega, let's start from Im. If you know effective current, you can calculate maximum current because you know that I maximum is equal to I effective multiplied by root of 2. I effective 2 multiplied by root of 2. Then better to leave like this. Many questions they are leaving it by root. They don't multiply it. So next omega. Omega is equal to 2 pi f. 2 pi f is given as 50, which is equal to 100 pi. 100 pi, leave it as 100 pi. This is omega. We got Im and omega, Vm is required. You can get Vm by two ways. Again, you can use the effective value of the potential difference here. Vm is equal to V effective multiplied by root 2. Vf effective 125.6 multiplied by root 2. Let div like this or multiply it like. You can continue according to the choices. And we got the Vm. Now we are ready to write the expressions. Im is 2 root 2. 2 root 2 sine omega is 100 pi. This is expression for electric current. But expression for potential difference is Vm is needed. It is 125.6 root 2 multiplied by sine omega. Omega is 100 pi plus 100 pi t plus pi over 2. 100 pi t plus pi over 2. This is the expression for potential difference. These are two questions about the pure inductance circuit.